Anyways, thanks for coming. This is our second meetup for Systems We Run. Today we have Brian Cantrell. I'm from Himeo. This is, so we help sponsor this, and we just want to make it a good time and share a lot of knowledge. So if you know anybody who can be a speaker or anything, please come to me afterwards, and then we can talk about that, because we're always looking for new people with new stories and new ideas to share. After this, we do have a little happy hour thing that we want to invite everybody to. If you want to come up at the Patriot House, just come follow me in my blue shirt, and we'll piper it all the way up there, and have a good time and share stories. So without further ado.
All right, I didn't realize we were going to go to Patriot House afterwards. Patriot House is famous because it was on Bar Rescue.
Oh.
We used to get, it's a terrible joint. And they, I mean, of course you're on Bar Rescue. It's like you're not on Bar Rescue because you're already good. And it used to be called the Holding Company. And so they, on the show Bar Rescue, they go into what was the holding company, and this guy totally redesigns it. And he decides that they should have a New England patriot kind of theme, which is like classic Bostonian arrogance. I mean, you're in California. Like no one, the only people that want this are ex-Bostonians, right? Right, exactly, right? And just a message from the rest of the country to Boston: the Patriots are the most hated team in America. Okay, let's just get that out there. So anyway, Patriot House. So they redid it, the Patriot House, but they only kind of like half redid it, and everything that they did that was new is now falling apart, and it's still run by the same feuding Irish sisters, and the service is still terrible, but it's fun. I mean, it's like we should go hang out there. Anyway, it's famous. Hey, I'm Brian Cantrell. I'm going to warn you, this one might be a little more meandering than usual. I don't think I'm in the middle of a midlife crisis, so I just want to give that disclaimer. I'm pretty sure that I'm not, but. I don't know, maybe in retrospect I was. But I am, however, kind of at a juncture, and I'm actually going to sit down. I'm at a juncture that I think a lot of people are at, where I am trying, so I've been a software engineer. The first time I cut code for money was in 1994, so 1993. So I have been a software engineer for whatever it is, 20 some odd years. And I plan to be a software engineer for 20 some odd more, at least. I'm kind of at hopefully not yet the midway of my career. And I'm kind of, and this may be the part where maybe this is a midlife crisis, but reflecting on what the back half of my career is going to look like, especially from a programming language perspective. So I just want, if you indulge me a little bit, I want to give you my personal history of programming languages, with the caveat that I am not a PL person. I'm not a programming language person, which will become obvious. But of course, I'm also not a linguist, but we use language, right, as a notation for thought. We use programming language as a notation for the systems we build. So the language is very, very important, but I'm a systems person, not a PL person. So for me, programming languages need to function. They need to work. They need to be deployed into production. I'm not interested in things for their own sake. I'm not interested in kind of, autoerotic syntax and sugaring. I'm not interested in that. I'm really interested in actually deploying things into production. So that's really my focus. Of course, that wasn't my focus when I first started in computing. My first language, and I'm going to date myself here totally, but I imagine there's some other pieces of similar vintage, was this terrible language called Logo. Which in retrospect, one of these things was I was thinking, reflecting on all the languages, I'm like, I guess the first language I ever used was Logo, which in hindsight was kind of child abuse. Logo is awful. And if you read the Wikipedia page for Logo now, you'd be like, well, this is fine. It's a Lisp dialect that influenced you. It's like, no, that's all wrong. Logo was a turtle that didn't know how to do anything. And by turtle, I mean like a triangle on a CRT that couldn't do anything, and the magic of it was you would tell it to box, and it would tell you, I don't know how to box. And I remember I was in third grade, and in the kind of the mandatory computing class, as was kind of my vintage, and I remember feeling, for someone who wasn't necessarily prone to this, but feeling overwhelmed with apathy that this thing didn't know how to box, didn't know how to make a box. I don't care that you don't know how to make a box. I don't think it cared that it didn't know how to make a box. Like, no, and then you would tell it, it's like, no, you make a box, but you go, forward 5, rotate 90, forward 5, rotate 90, forward 5, rotate 90, and then you would tell that like that's how you box, these kind of 4 steps. And then you could like type box and it would make a box. And I still didn't care, and I don't think it cared. Like my first exposure to computing was just like one of total like, I do not give a shit at all about this thing. And I think that was, I don't know, maybe it would be great to find the person for whom logo captured me. Like my ability to make arbitrary shapes just opened up this incredible world of programming to me. But anyway, I kind of don't buy it. Then the next language that again, very typical, this thing called BASIC. And because I think that, the kids today, I say this as the father of 3, the kids today definitely don't know what BASIC is. So I don't know when BASIC, somewhere between then and now, BASIC justifiably fell out. BASIC was the beginner's all-purpose symbolic instruction code, so it has to be screamed, of course. BASIC was very bad. It had this idea of, it wasn't structured, so every statement has a line number associated with it. And all of your code flow is by indicating the line that if a condition is true, you're going to go to this line, or you're going to go sub another line, which would kind of execute a pseudo function. But it was kind of all we had, and I liked making software. So I started making software when I was a kid, and being deprived of a graphics card, I had to write my own games. I feel like my kids get bored when I say this, so I'm telling you, hoping you'd be slightly more interested. But I also thought that I understood computing very quickly. Because oh, this is great. I understand what computing is, and I'm not interested in it. This is fun, but I actually want to go do something else. Through high school, I did do some computing. I used Turbo Pascal and started using Pascal. I've been people have used Turbo Pascal. It would be great to get Turbo Pascal, because Turbo Pascal was very, very fast. Compiling, say, I remember I had like a 5,000 line program that Turbo Pascal would compile in like 700 milliseconds on that's a 16 megahertz machine. I mean, does Turbo Pascal compile in femtoseconds? Does it actually does it compile code before it's actually written? I mean, it actually goes backwards in time, right? Turbo Pascal was an amazing compiler by a company called Borland. But again, I was not interested in any of this stuff. I was interested. I used it. It was fine, but it was not kind of what really motivated me. I got to university. I thought I was going to be an economist. Ha ha ha. And then I took my first real computer science course, first real economics course. And discovered, of course, that I was much more interested in computer science. And that became kind of my first earnest journey into programming languages to actually do something that I wanted to actually do something useful with. And the first language was C. And my first exposure to C was, I think, like a lot of people's first exposure to C, where you're kind of winging it. You don't really understand what's a star and when do I star things and when do I not star things, and you're kind of cutting and pasting code and copying it, and then it's failing spectacularly, and you're like, okay, that's too many stars, delete some of the stars. And actually I remember feeling, and it was a good feeling intensely frustrated that I couldn't get something to work. And I think part of an education is feeling that intense frustration and being able to push past it. I had like an errant semicolon or something, but I could not find it for the life of me, and I thought I was going to actually sob as a 18-year-old who should be beyond the point where they're sobbing over a stray semicolon. But the ability to deal with that frustration and get past it was great and very important. And C was I don't think I was actually C was programming me more than I was programming it. Suffice it to say, for kind of the first exposure to C. But I got better with C. I began to understand that there's this thing called the heap, and there's this thing called the stack, and what memory was, and you understand, okay, now I get what a pointer is. A pointer is actually just an address in memory, and that was all really solidified by the operating systems course that I took in college, which was great. I took this OS course where you, and if you don't have a Form formal education in computer science, or if you didn't take an OS course, I would still recommend you go back and just learn an operating system from first principles a little bit, because it's one of those things where you get so much information that you don't know how you lived without, as you begin to really understand what lives between the software that you write and the machine that's actually executing them. And it was very captivating, so captivating. I mean, I loved the idea of, the operating system, and I effectively have done kernel development ever since, but I just loved the fact that the operating system was creating abstraction out of the machine. And the fact that, and I don't think, I'm not a control freak, so I don't think it's that aspect of it, but the idea that but there was something empowering about just being able to deschedule something and not ever schedule it again. I mean, I feel like, you know what, you're gonna go wait in a queue, and I'm not going to wake you up. I don't know why you would do this, but it just felt like it feels like you're in control of heaven and earth when you're in the OS kernel or any runtime, right? So that was great, but it was the early 90s, and of course C was considered to be kind of this relic, and there was this new thing that was very exciting called C++. And I got very excited about C++. I mean, and it was hormones, really. In hindsight, it was the raging hormones of a then 19-year-old that just discovered this whole. Now, at this point, I understood enough about these languages to really want now all of this abstraction. You're at this buffet of abstraction with C++, and you can overload operators. You got multiple inheritance. You got polymorphism and virtual destructors, and you're just you're at a party with way too much hard drugs. And I basically woke up in the gutter, but years later. So I remember being extremely enthusiastic about C++. I did engage in my own kind of child abuse when I actually retooled the OS course as a TA to be in terms of C++, which I later deeply, deeply, deeply regretted. And there's fortunately a generation several years behind me then retooled it back to be in C, which I was greatly relieved by. But we did effectively a native object-oriented operating system because it was the fashion of the day, all in C++, and I loved it. It was great. And yes, there were, sometimes it took a while to get things working, but I loved it. And one of the professors in the department overheard some of my enthusiasm about C++, and like a grim apparition from the future, told me, once you've written 100,000 lines of C++, you won't love it anymore. And I was like, no way, man, I love this stuff, or whatever. I can't even remember what I said. I just kept plugging away and did all sorts of things in C++. Fast forward maybe 2 years later, and I am in hour 3 of debugging what I now know to be 2 totally distinct compiler bugs. And this is in the early day. If you used the Sun compiler back in the day, I'm just RFing templates.db on every compile, because this thing would try to reduce compile times, would keep all of this information around that was all wrong, and so I'm trying to chase down these 2 different compiler bugs. Every time I try to isolate one of them, the other one would come and start punching me in the face, and I go to try to isolate that, and I had this moment of I am trying to instantiate a list template. That's what I'm trying to do. And I know that I can write a linked list in 45 seconds in C. I can write a linked list really, really, really quickly in C. As fast as I can type, I can write a linked list in C. What am I doing? Why am I spending I'm spending 3 hours chasing myself around the room looking for my underwear, where I could just I could actually just be done by now. And I literally typed the semicolon. I'm done. I'm walking. I'm not writing another line of C++. I didn't resolve either of those compiler bugs. Did not write another line of C++. And I swear it is when I hit the semicolon on the 100,000th line that I had the. I think Steve Rice was from the future. This professor that had warned me of the 100,000th line. Of course, the difference between Rice and me is I stopped. He kept going. I think he still does in C++. So I left C++ for dead. I'm done. I'm moving to the country, and I will only actually operate with hand tools, namely C. Like what I wanted to do was C. What I wanted to do was kernel development, and I wanted to do industrial kernel development. I went to work at Sun, and purely in C. And it was actually kind of a funny time to be at Sun because it was 1996, which is when I went to Sun. And of course, it was Java, Java, Java. I mean, the cafe that we ate at was literally called Java, Java. Like, I mean, it's like, and we had, and Java was this tsunami because there have been all these different languages, including C++, and it just felt like Java was, to the world, it was the second coming of Christ. I mean, it's hard to come up with an analogy for it. It just felt like everybody was ready for Java when it happened, and everything was going to be in Java. Absolutely everything was going to be in Java. Sun took this to, not only were the cafes named Java Java, Sun had the extraordinarily bad idea to not only implement operating systems in Java, which at the time I knew was like, that's obviously a terrible idea, but to actually implement microprocessors in terms of Java, to actually implement like Java bytecode in silicon. It's like, this happened. This actually, I didn't make this up. I know it sounds like a fever dream, but this actually happened. And there were like 3 different microprocessors. There was Ultra Java, I believe there was Ultra Java, Pico Java, and Nano Java and Pico Java. It was going to be Java everywhere. And it kind of entered, there was this time of, and I don't think it was only because I was at Sun. I mean, those of you who were alive at the time, you can correct me if I'm wrong, but it felt like everything was going to be in Java, and there was no room for anything else. If you were working on C, as we were, you were relegated to a legacy system. Like, ultimately, Java will replace you too. The only thing that was slightly good news about this is I felt like, okay, C++ is definitely a casualty of this. Like, C++ is definitely dead. So I guess I'm pro-Java in that regard. For my entire life, I've written exactly 200 lines of Java. I wrote, like, at some point, I'm like, all right, I should actually write a Java program. And I'm like, this is very nice. This effectively improves everything about C++. For the most part. I see no reason for C++ to live. I now feel absolutely confident that this will destroy my enemy, and the enemy of my enemy is at least my, I have animosity towards Java in that regard, so this is good. Get C++'s pelt on the wall for sure. But it's not for me. Like, I want to actually continue to implement in C. And I wanted to continue to implement in C for a bunch of reasons. And we were rightfully resistant to the idea of an operating system kernel being written in Java, because that, makes no fucking sense. But the idea that you have to have something that is actually implementing the runtime, right? You have to have something beneath the runtime, and the abstractions that make writing software quick cut against you once that software is written. Like, once the software works, you actually don't want it to be in Java. Certainly you don't want your operating system kernel to be in Java, the thing that actually does manage heaven and earth, the thing that actually manages memory, the thing that we've got a structure that represents a page of memory in the system. And that there is one of those structures for every page of memory in the system. Every bit that is in that structure is a tax that's coming out of your memory. That is a percentage tax of your DRAM. It's really important to control stuff. Java, and this is still unbelievable to me, Java had no unsigned type, which I gotta believe was like a fuck you to C. And that has to have been deliberate. That has to have been like, no, I know about unsigned types. I'm just like good luck with them. That's my belief in unsigned types. Like, have some signed integers, and good luck with your hardcore systems programming in my language. I gotta feel that Gosling had it out for, because it makes no sense. Like, why would you not have unsigned types? But needless to say, you need unsigned types when you are going to actually interact with the hardware. You also need to be actually compiled to binary when you're going to interact with the hardware. Like, you can't be JITted to do it. So we knew that the operating system was going to be in C. It was not going to be in C++. And then so for me personally, that was kind of like the state of my world. It was still all C. And when I say all C, there's some qualifiers on that, right? Because there's an ecosystem that grew around C. that allowed us to make highly reliable systems in C. I mean, I think it is a bit of a myth that like, oh, nobody knows how to write safe C. It's like, that's not exactly true. C makes it hard to write safe C, and there are times when it makes it very easy to write dangerous C, but there are definitely people that know how to write safe, multi-threaded C. Now, that said, we developed a lot of custom tooling over the years to allow us to do that. And when I say we, I mean anyone who is developing a serious C-based system, whether it was an operating system kernel or a database kernel, spent a lot of time actually developing debuggers, we developed a lot of postmortem debugging technology. We developed linters, right? We used linters. We used developed tools to enforce style, which is, I think, very important. On the one hand, you don't want to like fall into wars over white space. On the other hand, the ability to parse something quickly, it's important that it's formatted in a way that looks familiar to you. So we developed this whole ecosystem that allowed us to develop and deploy and debug highly reliable, highly performing C systems. And there was no reason to kind of like move away from that. Like C is working, or what it was and is working for those lower level systems. But there's this kind of question about like, well, what about the software that's kind of above these systems? That you got, yes, the operating system kernel, fine, that's in C. But what about the system software in the database? Like, okay, I can kind of go either way on that. But what about the system software that's further up stack? What is the right language of choice for that? And for us, that was C, but admittedly, you get up there to implement these things in C, and it can be, it's frustrating. It can be frustrating. And frustrating not because we don't know how to do it. Frustrating not because like we don't know how to call free. Like it's really not hard to call free, actually. I mean, like people know how to do that, right? You can like put away your toys. You can like allocate things and call free later without like cutting off your face. I mean, it's actually not that hard. The problem with C is that the language doesn't help you at all in terms of any kind of interface contract. So the problem with C is not that it's hard to call malloc and free, because it isn't. But what it is hard is actually composing software that deep in that stack of software that you want to rely on, you've got software that's something's being dynamically allocated. Now, how are we going to deal with the failure of that? Failure to dynamically allocate that? Whose responsibility is it to free it? And we developed kind of, and if you go through the software that we developed over the years, you'll find certain patterns that we would use again and again and again. We would effectively develop these object-oriented systems where, a noun underbar create would create one of these things. You'd get back a handle. Then noun underbar verb would operate on one of these opaque handles and would do things to it. Noun underbar free or underbar destroy would just destroy one of these things and destroy everything. So we would do that, and we could do that and could compose software, but the reality is nothing enforces that. There is nothing that in fact, one of the things that I'm amazed that I do, that the rest of humanity doesn't, is structure prefixing, which is a really simple, in C, when you have a structure, every member of a structure has a 2 or 3 character prefix that is quasi-unique to that structure. And when you have, n hundred thousands of lines of code, n millions of lines of code, and you're trying to understand where this variable, this field is manipulated, if that thing is called I or next, and you're using cscope, which is a tool that we would use to allow us to develop C in the large, you would have no chance of finding this thing. So we developed a lot of these practices. Some of them we wrote down, some of them we didn't. But we got good at developing this kind of squeaky clean C. And we could do that up stack, but it was just painful because of this challenge with composing software. And so in 2006, I wanted to go off and do something else, and I'd done a lot of OS development, and wanted to go develop some upstack software. And there was kind of a question of like, what are we going to develop this in? And 2006 was post a very important moment, I think, in practical language history, which is the Ruby on Rails video in 2005. So if you were alive at the time, I feel, and again, feel free to correct me if you disagree, if you were alive at the time, disagree. But I feel that the Rails video is what destroyed the idea that everything was going to be written in Java everywhere. Because at least for me personally, because it was, you had a language that wasn't Java, that was kind of an anti-Java, actually. And in particular, Rails was an anti-J2EE. Of course, those animals have long since walked upright with Rails. But bear with me here. That back in the day, Rails was way, way simpler than J2EE. And hey, here was a way you could build a web app in this 15-minute video. When YouTube is like brand new, which is kind of amazing, right? That YouTube feels like it's been around forever, and that's only 13 years ago. DHH has this, David Hannemeyer Hansen has this video about actually building the software, and it's of course very frameworky and so on, but you could actually get something working at the end, and it was this kind of explosion of, and it's also coming at the time when the internet is in kind of a new phase of where it's not just a kind of connecting different computers, but connecting different people. So you had new ideas could travel further and faster. You had these languages were not going to be proprietary, and things that had been around for a while, like Python, all of a sudden resurged. You'd be hard pressed to find Python in production, I would say, in 2000. But in that post, again, feel free to correct if I'm wrong. I'm winging it here a little bit on the history, but it feels like post 2005, lots of things were on the table. So we were going to go build this. We were going to go build a storage appliance at the time at Sun, build something new. And there's kind of a question of like, what are we going to build this upstack software in? And I remember thinking at the time, well, we should do it in Ruby. It was a totally uninformed opinion. And like, thank God, this is one of those moments where it's just like, my God, like thankfully, the person who was in the room with me was like, that's a terrible idea, we should do it in C. And that was the end of it. I didn't like press it. And that, like, if he hadn't been in the room, or like if he'd been like, yeah, I don't know, we should do it that way, I could have wasted a year or two of my life easily and been a much more bitter person, because Ruby would have been the absolute positively wrong decision, especially circa 2005, 2006, when Ruby was still very, 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 very new and very. I mean, if you think Ruby's inefficient today, Twitter was a big customer of ours, and kind of in 2007, I went into Twitter because I feel like I'm like the internet historian here, but back in the day, there was this thing called the fail whale on Twitter. Do you remember the fail whale? Okay, right. So Twitter would constantly keel over. You'd get like this whale that was indicating that like things were awful, and it was threatening the company. I mean, like people wanted to not use Twitter as a result of this. Little do they know that there would be lots of other reasons to not use Twitter in the future, but this is back in when the reliability of the thing was its biggest problem, not like the Pepes or whatever. So we went into Twitter to try to help them understand what was going on, and using dtrace to understand where it was spending time. And I remember they were spending, it was like 460 milliseconds of compute for a request. And you're like, do you mean microseconds? Or like 460 milliseconds? Well, like, okay, there's I/O, like you're I/O bound. Like, no, we're not I/O bound. It's like 100% compute bound. It's like 400. Are you sure that's right? That you're spending for one request? Yeah, for one request would spend 460 like. Are you sure it's a millisecond? But it was milliseconds. And actually, it turns out what they were doing, it's kind of interesting, and it shows the peril of language choices. They were spending all of their time in bcopy, like 100% of their time in bcopy. Why are they in bcopy? They're in bcopy because they are bcopying symbols out of their stack. Why are they doing this? Because they are deep in their Rails app, and it was thought that to actually iterate over all of the elements of an array from 0 to the length of the array, like that's way too pedestrian. Like that's like repeating yourself or whatever. That's not dry or whatever. I don't even know what the dogma was at the time. The right way to do this is to just blast through the array until you fall off the end and get an exception thrown at you. And so, yeah, right, exactly. You're like, Yeah, well, it was, anyway, I don't know what to say about it. So what would happen is it would go flying off the end of this array, it's like a 4-element array, and it's like hitting the 5th element. And of course, it's an exception, and exceptions should be exceptional. And when that exception is generated, what Ruby would do is like, all right, I now need to get a full stack backtrace, so you've got some hope in hell of figuring out where this random exception is, because the alternative is much worse. The alternative is like something somewhere in there died, and I got no idea where, but we're now dead. I don't know what's on. So you don't want that, right? You want to have a stack backtrace you can debug. So it would walk up whatever it was, 434 stack frames, and for each stack frame, and this is where you get to the point where it's like Ruby could be a little bit more efficient. For each stack frame, it's like looking up the symbol, and this kind of like very inefficient mechanism for looking up a symbol. It would generate this huge like string buffer, like this 16K string buffer, and it would like, all right, time to like get this ocean liner upstairs. It would kick that up to literally like the collar of this thing. It's like, oh, I got it. And that's fine. I'm off the end of the array. No problem. I got done it, but I've done it the right way. I've done it without repeating myself or whatever. It's like, oh, God. So that was obviously very bad. And I mean, it highlights a bunch of things. It highlights the cost of some of these abstractions, the runtime cost of some of these abstractions, how difficult it is to find these things when they misbehave that way, and how easy it is to abuse these things. So anyway, Ruby was definitely not the right call for that. And we did that user level daemon purely in C. So that was all in C, talking over, effectively talking HTTP. But this was back in the day of Ajax. Remember Ajax? Ajax is, and again, I apologize for like the Antiques Roadshow, but this is what I do. So Ajax, terrible acronym. Ajax stands for asynchronous JavaScript and XML. So yes, one of the letters stands for a conjunction, which feels like that feels wrong. One of them is for an actual like abbreviation, which also feels like that feels wrong. And then one of them is for JavaScript, which is, I mean, it doesn't even make sense. But Ajax definitely was a nice buzzword. And this is when the world was discovering that there was an actual real programming language sitting in the browser. And this, Google Maps, Google Maps maybe is 2005, 2006, somewhere right around there, right? And I feel that I mean, again, correct me on the history, but Google Maps is like the first thing where you like, when you use Google Maps in the browser for the first time, you're like, what are these guys doing? I mean, it was so wild that you could like scroll up, and then all of a sudden, like new parts of the map would fill in, and you had people kind of quickly reverse engineering what was going on. And what was happening was there was this kind of nutty wart in the browser, this XML HTTP request that was not designed for what it was being used for, but basically allowed you to generate these programs that would sit in the browser and had this conduit of communication back to something speaking over HTTP. That's what it boiled down to. And we, like many, like, well, this has to be in JavaScript, so because that is the lingua franca of the browser. And I would say, so JavaScript became like really my first real additional language since C. I mean, there have been some, and maybe now's a good time, but there had been some diversions on there. One of them, I remember when I was a sophomore in college, going to a career, one of these hedge funds was recruiting at school, this like super AAA personality, was like, how many of you know what awk is? Like, everyone's thinking it's awk, right? Raise your hands if you know awk. Everyone raise your hands if you know awk. And of course, everyone's like, I didn't know awk, so like, no hands were going up. He's like, nobody knows awk. Like, nobody in here knows awk. And he's like super steamed. And I was actually worried, I don't want to volunteer I know awk, but clearly this person is very upset that no one knows awk. And he was enraged. I'm like, I definitely need to go learn awk. I definitely learned awk like that night. I'm like, what is awk? I need to go learn it. If you don't know awk, awk is a great small little language. And there have been a bunch of little small languages that I had added to the repertoire. We had actually invented a language called D, not Digital Mars's D, not Walter Bright's D, but a non-Turing complete language that we use for part of dtrace, which is definitely inspired in part by awk. And of course, we use Perl and Bash and all. So, I'd use all these other like little languages as part of, as kind of this interstitial kind of stuff. But the core of what I was doing was still very much in C, and now JavaScript. And with JavaScript, again, and I feel like there were so many of us doing this exact same thing at the exact same time. You're just like, all right, JavaScript, I guess, like, here we go. I got to hold my nose and got to be the first person with a computer science degree to actually like go into JavaScript. And the books on JavaScript were terrible. The best book was the JavaScript, the Definitive Reference, which is really designed around like a web page. I mean, it was not a JavaScript book. And at some point in time, like despite the lack of material, despite the terrible books that were out there, because there was not a lot of online material, you actually like figured out like, wait a minute, this is a real programming language. Like they're actually like, closures are actually incredibly powerful. I mean, this is my first time of actually using closures in earnest. And you realize like, wait a minute, you can do a lot of stuff with this. And then you kind of have this like epiphany, followed by kind of like anger and resentment of like, wait, why did we make JavaScript? Like, first of all, what's up with the name? Honestly, like, Brendan Eich just got railroaded on the name. Basically, it was LiveScript, but everything was Java. So of course we can't call it LiveScript. We have to call it JavaScript. It's like, but it has nothing. It's like silence JavaScript. So that's how we ended up with Java. I mean, terrible name. And there was no book. Brendan Eich never wrote a book. Like there was no, if you, and I would definitely recommend in terms of awk, like read the awk programming language. It is a book that is like 140 pages long, and you start at the beginning and you'll finish like 2.5 hours later, and you will know everything there is to know about awk, and it's beautiful. There is nothing. And we very much modeled, when we developed the dtrace documentation, we modeled it actually on the awk documentation. There is no equivalent in JavaScript. There's no Brendan Eich walking you through the decisions that were made and why. And later stuff is, and Doug Crockford, who was also at Yahoo at the time, that has done a bunch of writing where you can get that stuff more easily now. But JavaScript is a real language, and it was Lisp in C's clothing, and I like C's clothing, so that's fine by me. It was this kind of, again, epiphany for us. We developed that app. We did not use any. I mean, the whole idea of using a framework seemed kind of stupid, because it's like, I'm happy to be like on the raw DOM, like I can be like on the metal of the DOM, like it's okay, like I can manipulate the DOM, like it's so hardcore. It's like, it's really not that hardcore. It's like an API. It's like, it's really not like, we're not on the metal here. This is and I still like to manipulate the raw DOM, because it's the DOM is actually, and the DOM is what it is. And I think a lot of people would conflate the DOM with JavaScript, right? They would kind of have this venom towards JavaScript. It's like, actually what you hate is the DOM, is not, and the DOM just has like weird things in it because it evolved over time and it's very forgivable. But anyway, that is to say the warts in the DOM are very forgivable. So that was JavaScript, and meanwhile, we had to build a CLI for this thing, and I'm like, well, the CLI, and I started to build the CLI, just like seemed like the natural thing, and this is one of these things I didn't really think about it, and I mean, how many systems start this way? Like they just start as like the 100-line thing, and then it's like a 200-line thing, and then it's like a 1,000-line thing, and then it's like, well, I don't want to rewrite it, and the next thing you know, it's like a 40,000-line thing, right? And this is what was happening with this thing that was in Perl, and Perl, if you've ever done, I think Perl is I feel like Perl's kind of going away. And I know that like the hardcore Perl folks, definitely are very upset with the decline of civilization. But Perl is really an awful language to do software engineering in. I mean, it is truly, truly, truly awful. It just doesn't. It tried to bolt on a bunch of concepts like object orientation and exceptions that in a way that Perl 5 was very not receptive to. They did this crazy thing called Perl 6. They should have named a different language, whatever. Anyway, so I did this thing in Perl. I got to like 10,000 lines of Perl and had this moment of like, I am in the wrong language. Like, this is not right. None of this is right. And at the same time, one of my colleagues had taken JavaScript in SpiderMonkey and had developed this pretty cool testing harness for the stuff we had done using SpiderMonkey. And I'm like, we should build a JavaScript C hybrid. Like, that's what makes sense for the CLI. So I rewrote that CLI in JavaScript and C. And it was beautiful. SpiderMonkey has got such a beautiful C API. It was really easy to go do. It's not a C++ API, it's a C API. It's a really nice object model. It doesn't perform very well, but other than that, it was great. And it was really easy for us to build, and we were able to build the CLI really quickly in JavaScript. And I would tell people that this was at a time when if you were doing something of your free will in JavaScript that was not in the browser, like there was some stigma associated with it. Like among my fellows, among other software engineers, there was a little bit of embarrassment and shame over the fact that I was and the fact that I had such pride about it was very perverse. I mean, something was definitely wrong with me. I kind of felt like my wife and I met online in 2000. We're like the homesteaders of online dating. And let me tell you, there was definitely stigma associated with online dating. Online dating was like half a step above the personals on the back of like the free alternative newspaper when she and I met. And I remember one of her friends asking like, how did you meet anyway? And she's like, oh, it's a really long story. I'm like, it's one word. And like, not only is it like not a long story, it's definitely one word. And now, of course, like there's no stigma associated with online dating. But this is like JavaScript circa like 2000. JavaScript for elective JavaScript circa 2008 was definitely like online dating circa 2000. Like this is not something you brag about. But I thought it was great, and it was the right answer. Then the Sun was acquired. And we're not going to play that drinking game, so let's just say that Sun was acquired, and let's leave it at that. And I was looking for what's next, and I found this thing, Node.js, which was taking JavaScript and actually running it in a server side. And this was very kind of copacetic with a bunch of the things that that I had done for the CLI. I'm like, this makes a lot of sense, but certainly wouldn't make sense in SpiderMonkey or Rhino or whatever, but it did make a lot of sense as V8. So Node.js took JavaScript, but added V8 and effectively the Unix abstractions. Like that's what Node was. And it was super fast, and it was this total like epiphany for me personally. Like this makes tons of sense. And the company behind it was Joyent, a company that I knew for other reasons. I'm like, this is where I want to go work. I want to go work. And so Node was in no small part the reason I came to Joyent. And it was an era of great excitement, 2010, 2011 in Node. It was very early in Node, so this is definitely pre-Go, and Node is absolutely the highest performing dynamic language out there because there is a war going on in the browser for all these JavaScript engines. V8 developed by Lars Bach, who I had known from Sun. Lars had been a combatant in one of Sun's epic civil wars, a civil war between the hotspot VM and the exact VM, two rival VM implementations, a civil war that is still so hot and so close to the surface that if you find someone who is a combatant in that and just bring up the name, you will immediately know which side of it they were on, and they will become fiery with anger. It's great that a corporate civil war can actually still excite such passion so many years later. But so Lars Bach was a combatant in the VM wars and had developed a bunch of VMs, developed this very high performing VM in V8, and V8 was terrific. This made a ton of sense. So we went all in on Node, which in hindsight may seem like it doesn't make sense, but at the time it definitely made tons of sense. And I thought like we can actually, I feel it was like a Java do-over a little bit, and we can kind of do things right in terms of putting Node on the right footing for production grade software. And we at Joyent still use everything that we do upstack historically has actually been in Node, and we developed a bunch of tooling, and it was kind of like the C thing, right? Because, JavaScript, I've said this before, but JavaScript is the failed state of programming languages, right? I mean, JavaScript is an absolute free-for-all. Anybody can do whatever they want, whenever they want. It is ruled by feuding warlords, and ultimately, like everybody gets it. Like they kind of get their own warlord, and then like life isn't so bad, right? You can get like the food convoys through. But JavaScript it's bananas. It's a total free-for-all, and so we thought like, like I can bring order to it. I can bring order to the failed state. Ha 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 ha. And we developed a bunch of tooling to make Node much more robust. In particular, some of the things that we developed a bunch of libraries to make Node much more robust. We developed a series of best practices to make Node much more robust. Then we developed some truly eye-popping technology to allow Node to be debugged post-mortem. So we did things where if a Node service dies running a joint, we can determine what exactly was going on inside that node process. What objects were allocated, what was going on. Often when a node program would die, it would die because it's out of memory. Why is it out of memory? Because it has effectively an object leak, right? In garbage collected languages, you don't actually explicitly leak memory as such. It's not that you forget to call free. It's more that you have inadvertently created this object tree that you're holding onto, and the runtime has actually no way of knowing that in your mind you are done with it. It's like, well, you may be done with it in your mind, but meanwhile the actual software has a reference to it. So we can't actually free any of this stuff, and you're accumulating more and more of it, and finally we die. Actually, it's not that simple, right? We don't die. What happens is the GC starts running harder and harder and harder and harder. The GC is more, and everyone thinks like, garbage collection is my problem. It's like, actually, like, garbage collection isn't your problem. Garbage is your problem. And the GC is working hard to try to find stuff to free. It can't. And then finally, after hopefully not that long, but often after minutes of your service being unavailable or stuttering, finally it gives up and dies, right? And so, but from those core dumps, from that resulting OS core dump, we could actually determine JavaScript state, which was incredibly powerful and totally unappreciated, I have to say. This is not a condemnation of you, the public, but just in general, it was totally unappreciated. And people viewed it as, they viewed it as like alternative music or something, or like an art project or something where it's like, that's great for you. It's like, no, it's great for all of us. It's like, look, it's like penicillin. We invented penicillin. It's like, yeah, man, rock on, penicillin. Yeah, all right. Meanwhile, back to like my infant mortality. It's like, no, we can actually, but whatever, fine. And we began to just diverge. And there's a talk. It's actually last year. They wanted me to give a talk at Node Summit. I'd spoken at a bunch of Node Summits, and they're like, "We really want you to talk at Node Summit." I'm like, "That's really not a good idea." Like, no, like you should talk at Node Summit. I'm like, "We don't have anything nice to say about Node at this point. Like, I'm not. It's not. I don't. It's like, no, that's an even better talk." I'm like, "What's wrong with you? Like, you want me to show up to your conference and like not say nice things or take? Oh yeah, that'll be great. That'll be great. Like, yes. Like, all right." So I'm like, all right, how can I say the things that I need to say? Well, I don't actually want to not be nice. I want to actually, but we also had to say a lot of things. And in particular, what had happened was a divergence in values. That the values that we had, divergence is putting it, that is really putting it, because there was actually, there was never any convergence to diverge from. The values that we had for Node were values that Node never had for itself. Because Node, and it kills me to say this, but this is the truth. Node is JavaScript. That's what Node is. Like its core identity, Node is JavaScript. And at every single juncture where Node could choose between being JavaScript and being something that would be, we think, better for its purpose of server-side programs, it chose JavaScript. And I would say it. I mean, like the community chose JavaScript, and that's actually fine. I mean, that's there's nothing necessarily wrong with that. But JavaScript's values are all about growth and accessibility. How do we get more people writing JavaScript? And that's laudable. Like there's seriously nothing wrong with that. I mean, the fact that my 11-year-old likes to, code in JavaScript to like hack Minecraft or whatever it is he's doing. I think he's actually just watching videos on his phone, but I think he's trying to, he knows just enough buzzwords to get me off his case when that's great. And that accessibility is important, and I think that is terrific. But it took Node in a lot of directions that were not directions that we would take it. And we were out of step with the community on a lot of things. And there were lots and lots of issues where this came up. Promises was one where this kind of totally melted down. And I've got to think it's promises as a language construct, but the problem is, how do you deal with failure? how do you deal with errors when you have promises? And in JavaScript as implemented, if you have, I mean, God forbid you have a type error deep in something that you called via a promise, because it's going to be really excruciating to figure out what's going on. And the fact that, like, wait a minute, like, why am I getting, like, I've got a typo, like literally a typo in a source file. Like, why am I finding out about this through the worst possible way? Like, okay, if you have a typo in your source file, we are going to pick a relative of yours at random in a foreign country and burn their house down. That's how you'll know. It's like, can you give me a phone call or something, like a text message? Like, is this really the way you got to do it? It's like, no. And then, like, once we have enough of your extended family has been killed off in house fires, you'll begin to piece together what's going on. It's like, it's terrible. I mean, it's like, this is not the way to actually develop robust software, right? Apologies for the visceral metaphors. Sometimes I don't know who's driving. But and promises were where kind of things truly fell apart. And it's like, this is not our future. And we have exist and still exist, really. I mean, right now, still exist on our own crazy island of JavaScript plus C hybrids with all of this discipline around it about the way we write and debug. And it actually works for us. I mean, I know I've had people come in and it's like, well, Node is a disaster for you. It's like, it's actually not. It's actually, Node actually works we've gotten Node to work well for us. We have been able to carve out our own little villa in the failed state, and it's like we've got armed guards everywhere. But it's like, it's fine. Like, relax at the pool. It's fine. It's fine. Just travel with security detail. But it's not a future, right? It's fine for now, but it's not the future. So I've been in this kind of, and now we kind of get to probably the reason you draw here, in terms of this prolonged search for what is next. And I would really steer people to this talk I gave. So the talk I ended up giving was a platform as a reflection of values, and my observation was that it's not that Node is wrong or the JavaScript community is wrong. It's just that their values and our values, or my values, we'll just make it more personal, my values just don't quite line up. And C's values and my values line up really, really well. And that's why it makes that C is a really good fit for me. But C is not the right answer because of this composition problem. So what is next? And I feel like a lot of us are kind of on this journey right now of what is the replacement? And you get it feels like hardly a day goes by when there's some sort of these comparisons on either Hacker News or Lobsters or whatever between, what are the candidates to replace C? Well, there's C++. Okay, no, first of all. And don't come at me with the C++ 11 shit, okay? So I would liken C++ to a relationship I had in college where all my stuff was stolen and lit on fire. And it's like, no, they're totally changed. Totally changed. It's fine. They got kids, normal. It's first of all, I'm happy for C++, okay? Honestly, happy for C++. No, we're not getting back in a relationship. No, I'm not doing that. I'm not that dumb. I'm not, how much of my shit needs to be lit on fire before I, learn? No, we're not doing that. So C++ is just straight out, and I don't care, C++ 11, C++ 17, it's a different language. Great, fine, that's awesome, happy for everybody. I'm not doing it because it is still trying to be compatible with C, and that leads to a level of unsafety that you can't get around, coupled with this incredibly powerful abstraction. And it's like high schoolers. I don't know if my kids are actually getting to the point where my kids are now high school aged. Once you are a parent, high schoolers will terrify you. Because it is actually children driving adult bodies. That is what high school is. High school is a bunch of child brains running around in a bunch of adult bodies, and of course it's calamitous. I mean, what did anyone expect? And I feel like C++ is kind of the same way. C++ is you've got these very powerful abstractions, but there's this total lack of safety underneath it, and the failure modes are so grisly and so dark. So no, thank you on that. Then you got Go. First of all, again, I honor, I know lots of people love Go. I think that's great for you, and I got nothing against your life choices. For me, Go is kind of a lateral move from Node, albeit totally different. I mean, it's going from a failed state to a very strangely autocratic one. It's going from Somalia to Turkmenistan or something, where you're just all right, now the Grand Turkmen comes out and issues fatwas about renaming months or whatever, and it's just like the way things are developed. Because I just wish Go would say we don't feel like it a lot more frequently. Like we just don't feel like doing any of this shit. Like that's fine. Like I got no problem with we don't feel like it. But like as opposed to like no. There is no versioning because software shouldn't have versions. It's like, how about we don't feel like it? Can we just say we don't feel like it? Like, do we really need to have this? It's like, no. Like master should always be, software should be backward compatible with itself for all time. There is no, it's like, do we really believe that? And then of course, like, I don't know, we don't believe that. We've totally changed. No, the Grand Turkmen has actually been enlightened, and now we're going to do something completely different. But all right, fine. Go is just not for me. And there are a couple reasons. One, it's GC'd, and GC languages are fine, asterisk, but they are not fine for the kind of software that I want to spend the back half of my career developing. And that is to say, mission critical software, database software, like databases should not be GC'd. And I mean, I have always kind of believed that, but I had this protracted Cassandra nightmare that definitely, like, if you really need, like, deploy Cassandra if you really need to. I think nothing against Cassandra. It's like, it's not really necessarily Cassandra's fault. But when you got a database that's on a, like, 185 millisecond vacation, because, and you're being told by, like, the Cassandra experts, like, that's pretty good. It sounds like you've tuned your GC. It's like, it's got, wait, what? No, it's a database. Like, it can't take 185 milliseconds. Anyway, it's bad. So much of that, of tuning these systems comes down to this GC voodoo with the JVM, where you're trying to give it kind of different algorithms, different ways to GC to try to make these periods to lessen their impact. It's like, just no, like why? Once the software is correct, GC just cuts against you. It's not like Cassandra needs to be moving at warp speed anymore. It's like that actually could just be working in a language that's not GC'd. All right, so being GC'd is a major problem. The other thing that I really, again, kind of reflecting on it, one of the things that's really important about software to me is the way, in terms of system software, is how are errors handled. Error handling is really, really important. And this is something that I feel like no systems language has really gotten right. Because and this is kind of the drum roll, but if you could see, and C is infamous for this, right? Like you call something as like, does 0 mean success or does 0 not mean success? Right? The answer is it depends. It depends on what you're calling, right? For some things, the way we try to cut code is that 0 would always mean success, -1 would always mean failure, and more information was always being basically passed by reference and a handle you're dealing with. But again, that was kind of like a convention, and lots of stuff in the standard APIs you're dealing with have got different ways of dealing with something. Certainly, if you call something that's going to return a file descriptor to you, it's going to return a 0 or a non-zero result. So the kind of conflating that error condition with a return value is a major problem. Go's solution to this is like, okay, we're going to return both. And then, which is okay, fine, but now like, you look at Go code and it's like it's a lot of repetition, and whenever you're repeating, like you've got a human in there who's cutting and pasting, or there's just a lot of opportunity to get things wrong. So that I kind of honor Go, at least Go's taking a different approach on that. I like that, but it's not I don't think it's the right one. And then you got exceptions, which I fundamentally don't like and haven't liked and didn't like about JavaScript, don't like about JavaScript, because exceptions have this problem of kind of detonating out of nowhere. Detonating for reasons that you can't control, and then you're kind of relying on things actually being able to handle those, and it makes it hard to enforce correct software. How do you enforce that someone is actually dealing with error conditions? So that's one thing I'm definitely looking for, something that, so not GC'd, really kind of first-class error handling. And then the ability to compose software. And the ability to compose software requires some degree of safety. And again, it's not safety, not because of me. Like, I know I can write safe code. It's all the other jerks out there. No, I mean, to a certain degree it is. Like, if we had, I remember I wrote software back in the day to, from a core dump, find memory leaks. So we could find the C memory leaks, and we did that with some, a modification of the allocator, so we could actually get stack traces whenever we leaked memory. So we could see, like, where do we leak memory? And we really prided ourselves in, like, we're going to drive this daemon that we had developed to having 0 memory leaks, which was a laudable goal if it had not been using OpenSSL and libSSL at all, right? The problem is that OpenSSL had it just leaks on any condition. It will leak memory, and then you're like, okay, so you're looking at the routine that has leaked the memory, and you're thinking okay, so I just need this thing to be able to return, and you void. It's like, shit. Okay, so this thing is going to have to be modified to return a failure condition, right? Because I got to propagate this failure condition up. So this thing has failed, and now something that is calling it needs to free memory that it's allocated. That's where the nature of the weak is coming from. All right, so I'm going to change this, return an error code. Please don't be called in too many places. Called in 4 places. Okay, good. All right, and then you look at but one of those places returns void. You're like, fuck. Okay, so please don't be called too many places. Like I called in 20 places, and you're like, and then you get to one of those called in 4,000 places. You're just like, So you're done. You're done. You're gonna, you know what? We're leaking memory. 8 bytes. There you go. Have your 8 bytes. You're not coming home. I don't know. I don't know what to tell you. It's there's no way to bring that home. And the problem is where there's smoke, there's fire. I mean, actually, the reason that the memory leaks are really kind of easy to not have, and C software that has memory leaks always has other problems, and always has data corruption lurking, always has deeper problems lurking, and obviously all the problems we've had with OpenSSL. We were kind of doing this years ago, but all the kind of the problems we've had with OpenSSL are not really surprising, given what we could see based on their inability to kind of do these basic things. So that safety becomes important. So with all of that, you kind of look at what's out there. So it's not going to be Go, it's not going to be Node. There are a bunch of things out there. I mean, there is NIM. I think NIM may be GC'd. There's Zig. I know there's a rabid chicken scheme faction, truly a faction at Joyent. We had some OCaml fascination. The OCaml was definitely interesting, but it's also GC'd. There's Haskell, right? There's Swift. Yeah, exactly. But many of these are not systems languages, right? They're just not. Although I'm using Matterhorn. We've got Mattermost, and I use Matterhorn, which is actually written in Haskell. I've got real software written in Haskell, which is really very, very exciting. It's totally inscrutable, but very exciting. But that is also not. I mean, it may be a good fit for a CLI-based chat client, but not a good fit for kind of a database, right? A database in Haskell. I mean, I'm sure it's been done, but there actually was a very Perl 6. The first Perl 6 interpreter was actually written in Haskell in 2005, 2006. I don't know. So there's some stuff out there, and then there's Rust, right? And so Rust is obviously the one that's been looming very large, because you look at Rust, and there's a lot of my values and Rust's values really seem to line up in a lot of ways that are really interesting. So I've been in the period that I think a lot of us have been in, this kind of prolonged Rust curiosity. I've been reading a lot of blog entries, and whenever you read blog entries, I feel that a lot of that stuff, and it's a bit of an echo chamber effect as well. I mean, it's people get very hung up on borrow checking on the borrow checker in Rust, because the way Rust works is some basic knowledge of Rust. Rust is a non-GC language, but one in which you don't explicitly allocate and free memory. Rather, the compiler statically figures out when you're done with things. And then it gives you, the way it's able to do that is by being really, really conservative, and by making sure that two things aren't using things simultaneously, that when you've got one body of software that wants to allow another thing to mutate something, that it is explicitly lending this thing and returning it, or rather this software is borrowing it. And people do get hung up on the borrow checker, and I think that, and that was kind of my attitude before going into Rust. I'm like, okay, there's clearly this very steep learning curve around the borrow checker, and that is definitely, there is truth to that, but I think it's because people do kind of the wrong thing when they start doing Rust. So I would just say that, before I talk about kind of the experience I've had for the last, really not very long, last couple of weeks, honestly, where I've decided time to get over Rust curiosity and actually start implementing some real software in Rust, which I've been doing again for only a couple of weeks. I've probably spent maybe 40 hours, real hours, working on it, maybe more, but not that long. So I'm still very, very early in, but I'm far enough in to have gotten over a couple of humps. I do think that many people are, when you go into Rust, I would say you want to go in the right way, and that is one with a mindset that Rust represents some really important new ideas. and new for me, new for us, systems programmers. And this is where if you're a PL person, you've got every right to vomit in your mouth, because algebraic types are not new. I get that. Like I know algebraic types have been around for a really long time, and I get it. But they are new to me. I have not been able to use algebraic types because, to the best of my knowledge, Rust is the first non-GC language to actually have algebraic types. And so what's an algebraic type? An algebraic type is something where you have a type. I mean, you can view it as a glorified union in C, where you've got a type that can be one of these several things, and your code is basically going to denote one of these orthogonal conditions based on the type that's returned to you. But it's one of these enumerated types. And unlike in C, where a union, even by C standards, a union is C of its, I mean, just like unions are, and I would use unions a lot. Like I'm a major user of unions, but unions are, even by C's own standards, unions are borderline insane. I mean, the unions are like, to say they're unsafe is really to like, unions might be surprisingly safe given what they are. I mean, they're that dangerous. Algebraic types in particular, and I think one of the first things I really realized with Rust, and I think is the more important aspect than the borrowing and the safety and everything else, is the way Rust deals with errors. Because the way Rust deals with errors, and again, I know if you're a PL person, you're just like, I can't believe this guy like has discovered clean water and he thinks it's like brand new. It's like, yes, oh, wait, this is why we don't have cholera on OCaml. I'm like, okay, no, just bear with me for a second. I know that functional languages and F# and OCaml and so on have had these for a long time, but the ability to call something and have it return to you a result that is either a value or an error in the same kind of package, and it has to be one of those, and forcing your code to deal with those. And that's what Rust forces you to do. Rust forces you to, they've got pattern matching operators. You are forced to say, okay, if this is a result, because if it's a result, you can't just use it. The result, you have to unpack the result. And that kind of act, it feels laborious, but it's actually very valuable, because then you know, like, okay, this thing has succeeded, versus this is an error, and now I need to actually propagate this. And one of the things that I really like about Rust is it makes it really easy to propagate that. So one of the things that they, and I would say one of the things I like about Rust just in general, is it's been around long enough and they've been using it on real software long enough that they've changed course in some really interesting ways. They've added some interesting things. So one of the things they found is, hey, one of the things we're doing a lot of is this thing can return a result, which is a kind of it's on the one hand not a special type, on the other hand it's a first class Rust thing. A result is either it is something or an error. That something is genericized, so unlike Go, you have true generics. And we want to act on this, and if it's an error, we're going to return that error. We're going to propagate that error, and if it's a something, we're going to unwrap that something, unpack that something, and we're going to process it. We're doing that over and over and over again. So let's actually make that really concise, and they do that if you are in a function that returns a result, and you're calling a function that returns a result, you can simply call that function with a question mark on it and assign it. And what that means is, if this failed, propagate it, otherwise unwrap it and assign it to the variable. It is the most concise way of, so you can do things like, open this file, do this, read this, else seek, the things that we do in system software, and it's just like this question mark, that question mark, this question mark, this question mark, and you can just see it. It's right there. And I've totally handled every failure that can happen from this. Like, I know exactly what's happening. And if I need to differentiate between an ennoent and an eperm on an open, I know exactly where I need to go add that. There's no boilerplate in my way. It's very tight. It's very concise. It's very robust. I would be curious to know, I've heard different stories on the etymology of Rust itself. The fact that it features many of the letters of robust, I've also heard that it's kind of the idea of generating persistent software, and the idea of like Rust on software because it's been around for so long. And that's something that I'm very sympathetic to, because I've been in the same source base my entire career, and I've seen the power of software that works correctly. And we're not going to rewrite our operating systems. We're just not at this point. We're not. And by the way, like that's all. I mean, we're not going to do that in Rust either. So I have learned something from my past. And the idea of like, oh, we're going to rewrite the OS kernel in Rust. It's like, no, we're not. No, we're really not. There's no reason to do that because the operating system kernel actually functions correctly. Now, maybe we want to add some new functionality or we wanted the ability to write a device driver in Rust, maybe. But we're not going to actually go rewrite existing working software in Rust. But Rust does give us, and the zeitgeist of Rust is developing load-bearing software that will survive us. And that's something that I'm very sympathetic to, and I don't see really anywhere else. Like one of my friends, Peter Rameshan, has got a great line. If you want code by the pound, I'm not your guy. I am not a code by the pound guy. I'm just not. Whether that's because I'm a knucklehead or because I don't spit out code. I like to actually take my time and like solve the problem the right way. And I like to actually. I implement things. I will implement something once and then re-implement it, which I feel is like that's like not. Writers do this all the time. Like writers rewrite things all the time. That's why so much of writing is rewriting, and yet so little of the initial software development is actually like really churning on something and trying to get it concise and trying to get it the right way. But Rust really encourages that, and I really like that. So I love the error handling. I love the macro system is amazing. So part of the reason we were able to make C successful, we humanity, was because of this thing called CPP. CPP is the C preprocessor, and in the right hands, the C preprocessor can do beautiful, beautiful things. It allows for really powerful metaprogramming. And you kind of, certainly when I was much younger, I was this idea like don't touch the preprocessor because like only terrible things happen to the preprocessor, which is basically coaching a high schooler around abstinence, which makes total sense, and I advocate doing that. Because again, it's the child driving the adult body. But when you get older, you realize like, wait a minute, we can actually do this safely. And the preprocessor, you can use the preprocessor to do, and if you're in my code, or you've been in my code, or you can code to other people kind of from my school of thought, you will see the preprocessor being used to generate better code faster. And Rust takes that to a whole new level. It's got true or hygienic macros. So it's not just kind of this kind of CPP kind of expansion of things, but you can generate, the macro system is crazy, crazy powerful. And it allows for all sorts of things. It's kind of like this escape hatch where you can do, it's basically another language under there, where you can do effectively arbitrary things, but in a safe and hygienic way. And I think we're going to see that, we already are seeing it used in really interesting ways, but it allows you to like declare JSON, for example, in your Rust program. Like you can drop some JSON in there because you're using a JSON macro. Or you can use, so there are lots of opportunities to where things are kind of a pain in the ass in Rust. It's going to be macros that are going to help make that better. And I think it's coming from that kind of that scheme school of thought in terms of these very powerful macros, but in a systems language, where it's like something that we can now have. One of the themes of one of the Rust books I'm reading is like, we can have nice things. Like that's a big theme. Cargo is great. I really like Cargo a lot. I feel like Cargo has learned a lot from the systems that have come before it. And we had NPM was a source of huge friction at Joyent. If you've used NPM, it's the Node Package Manager. And at one point, we were trying to develop actual real software in Node and running into a lot of the issues you would run into, where it's just like, when I kind of like regenerate my software and it kind of like pulls in the most recent dependencies, like it's kind of a pain in the ass. Like it's very hard to I want to actually generate something that is the same thing, and I want to generate that same thing years later. I don't want to have the thing change it from underneath me. And there was and we are in EC2 here. Our offices were in EC1 at the time. And one of my most vivid memories from EC1 was like this showdown with the engineers that became almost an intervention with Isaac Schluter was was behind NPM, and one of the other joint engineers, Dave Pacheco, was really on the forefront of trying to get Node in production and needed the ability to freeze all of his dependencies, and it ultimately became shrink wrap. And shrink wrap ultimately didn't succeed for a bunch of other reasons, but ultimately is kind of the precursor to what became a lock file with Yarn and now with NPM as well. Now kind of like NPM has now seen the light, but it was an extremely tense like, no, you don't need that. And Dave's a very quiet guy and being like, no, I quiet but persistent guy of like, no, we do need this and here's why. And like the other engineers kind of beginning to weigh in. And I'm like, this is going to turn into a brawl. And finally the truce was, okay, if you implement it, I'll integrate it. It's like, okay, fine, that's good. With the piece in our time, great. Dave, go implement shrink wrap. But the cargo is great. I mean, the way cargo, and it's not unique, but I like cargo a lot. And then there's the actual like borrow system and the borrow checker. And I felt like I was having a good moment with Rust when we were having our first real fight. I mean, there's something, if you're in a long-term relationship, like that first crisis that you endure, like that's important, right? You gotta like, how are we gonna deal with it? Maybe like, someone's parents are sick or there's a health problem or like you got money problems, but like, how are we gonna deal with it? Like, is this relationship real or not? Like, are we gonna actually like see this thing through? Or are we gonna like throw pots and pans at one another and go, and go our different ways? And with, I did have that, and the borrow checker can drive you nuts in that it's very conservative. So it will say like, no, you're borrowing this thing here and you're using it again here. I mean, this thing was borrowed here basically, and you're using it again here. And it's like, yeah, but you can see that the thing that I lent it to is done with it. Like you, the compiler, like it's done with it. Like it's done with it. It's like, no, I don't know that. It's like, no, but what if I promise it's done with it? Like it is done with it. I'm looking at it. It's done with it. Like, is there any way? And I think one of those things which they probably shouldn't add because people new to Rust would do it all the time of like, how do I promise that I'm done with this right now? Like, how do I get the borrow checker like off my back right now? And of course, there is a way to do it. It's just this word unsafe, which is like, okay, I don't want to. Okay, I don't want to actually quite type the word unsafe. I'm not willing to go quite that far. But for a lot of things, what I found, and I think it's important that by the time you have your first fight with the borrow checker, it's important that you see some of these other, at least for me, it was important to have seen some of these other advantages to Rust. So I could see like there is so much promise. I mean, it's very fast. I mean, it's another thing that's important. I was actually benchmarking. I'm like, this thing's a dog. Like, why is it? And then I'm like, I'm now I want to get serious about benchmarking, and I'll put it into like, I'll actually use cargo to build a release binary, as opposed to, and apparently like, that's what's like, oh, you actually want to run this thing? Oh, okay, all right, yeah, okay. I saw a 20x speed increase from running with like release mode versus like, oh, okay, so clearly, and about 20x in build time too. So which is great, right? I mean, that says that the compiler is working hard because Rust can actually do what C could never do. It can really disambiguate memory, right? It knows who is using what when. And actually, one of our concerns was that the C compiler, we rely on the fact that our software very much relies on the fact that the C compiler can't solve this problem. And that if you call into a function that is externally linked, the C compiler has to be like, I've got no idea what's going to happen there. And I have to assume that when this thing comes back, all of my memory, I've got to reload all my memory basically. I can't assume that, you're passing this address over here. I can't assume anything. We have code that relies on that, absolutely. So one of our concerns was like, if the C compiler gets good at memory disambiguation, where it actually knows that this memory is actually not being accessed over here, and I can actually be much more loosey-goosey about keeping things in registers, we would generate errors in code. But with Rust, it actually can know that. It can know what's in use when, it can know what to inline where, and the compiler can be very sophisticated, and clearly is very sophisticated. I mean, it's really admirable what they've done, and I'm not a compiler person, but they've clearly done a lot of really great work there. So it performs really well. So you want to kind of be far enough along. For me, at that moment was like actually parsing JSON, like out of a file, which is a pain in the ass we have to deal with. The strongly typed JSON parsing with this thing called SERDE, I hope I'm pronouncing it correctly, SERDE, so the serializer or deserializer, it's amazing. It is truly amazing. The ability to pull something in a strongly typed fashion into your own structure from JSON faster than anything else, basically, is terrific and is very empowering. You want to be far enough in that by the time you are having that first fight with the borrow checker, you are willing to accommodate it, which is really the key with Rust. With Rust, you have to be like, just do it Rust's way. Let Rust win is kind of my lesson so far, is that you have to be willing to rethink the way, you've got I want to solve this way, and Rust is up in your grill, and the borrow checker's on you, and also Rust, there are things where it's trying to be helpful, and the compiler can be very helpful. Sometimes it's going to be I think you want to did you mean this variable, or add a mute here, or take this mute away, or do this, and you're okay, compiler, I'll do that. And you're oh yeah, that's great. But once you're in borrow checker hell, it's oh no, you meant to do this. You're oh okay, okay, I don't understand what I'm doing. Okay, I'll add a mute there. Then you run it again, and the compiler's oh no, all this other shit's wrong. Who told you to do that? I almost want the compiler to be who seriously told you to do that? It's you told me to do that. I didn't tell you to do that. I mean, the compiler could really gaslight you. You could be I am going insane because and there are moments where you're just I need to walk away. Okay, I'm beginning, I think I'm gonna cry. The compiler is, because the compiler is suggesting that I do all these things, and they're all leading to more and more problems. The other thing that is entertaining in terms of typos, one thing I recommend, how many of you have done Rust, by the way? I should have asked this earlier. Okay, cool. Actually, that's a lot of you. So I'm sorry if all this is wrong. If all this is wrong, definitely correct me. The thing that I found very valuable, actually, there are two great books, both of which are relatively recent. I've been carrying both of them. I'm not sure if people call it triple or not, but this is the Rust programming language. This just came out. I'm a paper person for the book. This is kind of your modern ARM. Effectively, ARM is the annotated reference manual for C++. My ARM was very well thumbed. This is great. I would also really recommend Programming Rust, which is the O'Reilly book. These books are very, very similar, but Rust is, there are enough big ideas in Rust that it's you got mom and dad. It's very helpful to have mom and dad. Both of them basically telling you the same thing, but slightly differently. And so there are lots of things, and they both have terrible indices. The indices are so bad. And I get that this is a hard problem, I guess, but the indices are awful in both books. So both books are very similar. I would recommend both of them. Programming Rust has got a little more narrative to it. And one thing that I did that I definitely don't regret is there's the authors of Programming Rust, so what Jim Blandy and Jason Orendorff, get you started with a program they've developed that does a Mandelbrot set. And it helped me a lot to just type in their program. I mean, I felt and one thing that was important for me that might be important for you, and again, for those of you who've already done this, apologies, you really need to learn Rust. You need to go back to, I had to go back to what it was like to really learn C or learn C++, versus learning other things more recently, which has been okay, I can pick this up really quickly. This is you're gonna need to learn this the way we used to learn things, which is it's hard, you've got to grind, and it was helpful for me, the way I learned BASIC, right? Where you're getting programs from Entree magazine and entering them in or whatever. That's probably the first Entree magazine reference someone has made in 20 years. But so actually typing the program in and then getting things wrong. You have typos, and then getting the compiler message when you get things wrong. And the compiler messages are generally, when the compiler is not deliberately fucking with you, which I'm convinced it must be, the compiler messages are actually amazingly good. I think because, and God only knows for those people who were in Rust earlier, I get the sense that this is something that's improved a lot over the years. Clearly, there's a lot of bad history here because the compiler is so verbose on things, where it's telling you no, here's where you're using it, and here's where you borrowed it, here's where you borrowed it immutably, and here's where you're trying to use it mutably, and I mean, it's very explicit and very, very helpful. And it was very helpful just to enter that stuff in and get something working before I was screwing around with my own data structures. Because the number one mistake that I think people are making is they're taking all right, I'm gonna take the most basic data structure, I don't know, a linked list. Let me go in for a linked list in Rust. You're no, turn back. And you're just you're going down a bad path, because the linked list is going to be bad. It's just going to be bad because especially if you make it a doubly linked list, which is going to be really, really, really bad, because Rust has this notion of ownership, and one thing needs to own one other thing. And a doubly linked list, it's like, well, who owns this node? It's like, well, kind of both of these nodes. Like, maybe change that to a mute. Okay, change that to a mute. No, just kidding, you idiot. Now you got all these other problems. Change that to a mute. No, I'm kidding. You won't. I know you will, but don't. You're screwed. And so you get these people who are like in tears writing these blog entries with like, I hate Rust. Understandably, like a doubly linked list is the absolute worst data structure. And then it kind of like, there's like this big anti-pattern, I think, where there's a little bit of people trying to like talk you out of the need for a linked list. Like, you don't need linked lists. Like, if you think you need a linked list, you're solving your problem wrong. And it's like, that's not helping. That's really not helping. Like, that is not like, because there are conditions under which, like, I know when I need a linked list, okay? And I know when I need a doubly linked list. Like, don't try to talk me out of my doubly linked list because your compiler is having me fetch rocks and then taunting me when I'm doing it wrong. But the problem is that problem is the wrong problem to go attack with Rust. Like, don't start with that problem. There are ways to do a doubly linked list, but if you start with that first, you'd be like, why the fuck would anyone do any of this? This is crazy, because you don't have any of the actual value, I think, of actually using Rust. So in terms of where I am, and I gotta notice how long I've gone, a little long, in terms of wrapping up. I've been at this for a couple weeks. I'm taking something that I wrote that is a C node hybrid, which is very painful to do because you have to deal with this C++ interface in the middle that is a giant pain in the ass. And I would love to never have to write one of these again. So I'm taking this thing that's basically in C and rewriting it in Rust, and which has been an educational experience in a lot of ways. Some things have been amazing, and other things have been really nasty. And I've got a pretty sophisticated data structure that I developed for this thing that I'm finding is really hard to mimic in Rust. And it's one of these things where like I gotta find a different way to do it. I think that's kind of the attitude you have to have when you're going into it, is that like you're gonna have to, there are gonna be some false starts, and there are gonna be some times when like you're not doing it the right way Rust wants you to do it, and you should probably just like back up and figure out a different way to do it. Don't just try to Google your answer. I mean, I think one of the things we try to Stack Overflow everything now, and like that's not a good way to learn Rust at all, I don't think, because I think you'll end up with a lot of anti-patterns and a lot of anger and resentment, and probably going on to do something else. I think there are a bunch of other great languages out there. I should mention Pony, by the way, in terms of my other survey of languages, Sean's Pony. But there are a bunch of other great languages out there, and I'm not necessarily, on the one hand, I am not saying that all of my software is going to be in Rust, but I do think Rust represents really interesting, important new ideas that are available to systems programmers for the first time. And I think a lot of people are going to investigate it really seriously. And speaking personally, I love the way the community thinks about things. And I love some of this. I mean, just one other kind of concrete example to wrap up on. When I remember encountering Rust maybe 3 years ago, and it had this green threads model. So a green thread is the end-to-end threading model. This is where you create exactly. You create a thread, because you can create your own thread, you being a process. Like a thread is just like a stack and some register state. And if you want, you can be like, you know what? Forget the operating system. The operating system is giving me this thread of control, and I'm going to implement my own little thread library up here where I've got all my own little threads and these little super lightweight threads. And there was this idea a long time ago that we want to have millions of threads. Terrible idea. And we're going to multiplex this on top of fewer kernel threads. This is again this end-to-end model or green thread model, and it's a terrible idea. It's a demonstrably terrible idea. Every system that has done this has regretted it. The ones that have regretted it properly have ripped it out. The others have just lived with it. And one of the things that was very impressive to me about Rust is, when I saw Rust doing green threads, you're just like, oh God, come on. But then, whatever it was, a year later, they're like, you know what? This is all a mistake. And they ripped it all out, which was really admirable, because one of the mistakes that I see programming languages make a lot that I have not seen in Rust is the desire to honor compatibility when no one's using the software. Like you get Python, right? Why is it that a constructor in Python is underbar, underbar, init, underbar, underbar? Listen, I don't have that many aesthetics, but that's a lot of goddamn underbars in a constructor that I'm going to be typing all the time. It's well, we didn't want to break any software in 1992. It's Yeah, for all 10 people that were using Python, like now the rest of us have got to deal with this like wart for the rest of our lives. It's like, no, we got Python 3 that'll break all the software. It's like, okay, that's not what I asked for. And I kind of feel that Rust made a lot of right decisions in terms of revisiting some of that stuff, some of that big stuff. And one of the other things they really revisited was around the ethos of performance and kind of hearing from people that like actually what people want is a high performing language to really go replace C++. And that really became their focus. So I think it's a community that I'm really excited about, and I intend to like finish up what I'm doing now, but I think based on what we've seen so far, we're probably going to continue to implement other things in Rust, and I think a lot of other people are going to as well. With that, thank you very much. Sorry to go on so long. Thank you very much, though.